In this video, we are going to talk about how to find the area of composite figures. So that means either two shapes that are put together or when you have a shape that is taken out of another figure. Now, in these problems, there are a lot of correct ways to solve them. What I'm going to show you might just be one method, and you might choose a different method, and that is totally fine. The only thing I'll say to that is that if you choose an approach and you see partway through that it is getting super complicated and you're having a lot of trouble doing the calculations, I would suggest go back to the beginning and see if there's another way that you can visualize the same problem. These problems, sometimes there are multiple correct ways, but one will be significantly more complex. And if you realize you're at a point where it has just gotten very complicated, try it again from the beginning, and you'll probably see that there is a simpler way to do it. So for this problem, I see a triangle with a height and the hypotenuse is shown, and then I see a square on the bottom. So I know I need to find the area of the square. So I need the area of the square, and I need the area of the triangle. And then, because they are put together, I'm just going to add them up at the end. Now for the triangle, I know that area is 1/2 base times height. And then for the square, I know the area is side squared. I start by writing out my formulas because I need to figure out what parts of my shape do I know, and is there anything I need to calculate before I can use my area formula. So in the case of the triangle, I know the height is 35, so I might even label that with an H, but I don't know the base. This side, it is not the base. As shown in the other video, base and height are always perpendicular to each other. So I know I need this side over here. Luckily, I see a right triangle and I can do Pythagorean theorem. So over here, I might do that the base is going to be 37 squared minus 35 squared. And that would give me base squared. If I calculate that out, I'm going to get 144. So I know that this piece right here is actually 12 if I take the square root of 144. Now, since I'm looking for the entire triangle, I'm actually going to multiply that by 2 and get that this side is 24 inches. You could also find the area of half of that triangle and then just multiply it by 2 at the end. So now that I have all the values that I need, I can substitute them into my formula. 1/2 24 times 35. And our area for that piece is going to be 420 inches squared. I can also do the same for my square. I notice that the side of the square is the same as the base of the triangle. So this is also going to be 24. So my area for this one is 576 inches squared. I do at the end have to put those values together. Just finding the individual portions is not enough to tell the area of the whole shape. So I'm going to add them up. And if I add them up, I get that the area is 996 square inches. And once again, you see there are units in every part of my answer. So in this case, I found the two areas and I added them. In our second video, in our second problem, you see that we have a shape and it looks like something's cut out of it. Now there are a couple of different ways that we could approach this problem, but we're definitely going to talk about what are some easier ways versus more difficult ways. So some people might say see a triangle here, and they see a triangle, but then we have this shape that's not exactly a trapezoid, it's not a kite, not really sure what to do. So then maybe we go back, maybe we try drawing this line. And now we have two trapezoids. But I wonder that, are we going to figure out what this side length is? Do we know what this small portion is? So now we're going to go back and think again. in this case, we can fill in this side right here. And we actually have a parallelogram and a right triangle. We know in a parallelogram that this side is also 23.8. So we can use that to find the area of the parallelogram. So we're going to do the area of the parallelogram minus the area of the triangle. And that'll give us our portion. So sometimes it's easier to think of, is there a rectangle or a parallelogram or a triangle around my shape? And then I can cut out the pieces that aren't shaded or aren't included in our figure. So in this case, I can find the area of my parallelogram. Area equals base times height. And I see that they give me the base and they give me the height. And for my triangle, I'm going to do 1/2 base times height. So let's focus on our parallelogram first because they do give us all the values. So our area is going to be 23.8 times 15, and that will give us 357 square feet. But if we look at our triangle, remember what we've talked about throughout these two videos, that base and height are always perpendicular to each other. So they give us the 21 and they show the right angle. That 23.8 is not going to be the height of that triangle because it is not perpendicular to the 21. So we're going to once again use Pythagorean theorem to find that third side of the triangle so we can find the base and the height. So if I use Pythagorean theorem, I am going to do that, like, the base squared is equal to 23.8 squared minus 21 squared. That is going to give me 125.44. So my base is going to be 11.7. Yes, let me confirm, 11.7. Oh, sorry, 11.2. 11.2. So if I have my base, now we can find the area of the triangle by doing 1/2, 11.2, and 21. So 1/2 of 11.2 is going to give us 117.6 feet squared. So I can now subtract those two areas, and our final area will be 239.4 square feet. So in this case, I had to go and subtract them to be able to find my final area. So what I want to emphasize with this problem is that you want to be flexible with the types of shapes that you're identifying in your picture. And I want you to think about that negative space, that space that's outside of the figure you're calculating that might make a more simple shape that's easier to know the area of. Thank you.